The Webb glance is such a long way out that it's catching light that has been voyaging for over 13 billion years. Yet the universe has been extending, and thus the light has been extending. For the most distant worlds, we're thinking back in time nearly to the Big Bang. The immensity of the universe might seem vast, but every last bit of it started from what we allude to as the singularity. As of now, this is how we interpret the Big Bang hypothesis. Anyway, the James Webb Space Telescope, JWST, has revealed significant mysteries about the birth and development of the universe, leaving us dumbfounded. Prestigious physicist Brian Cox has proclaimed that the noteworthy discoveries made by the JWST might actually reshape our understanding of the universe as a whole. The James Webb Space Telescope, named after the recognized NASA executive James E. Webb, remains a wonder in current galactic investigation. This telescope represents a huge mechanical leap forward from its ancestor, the Hubble Space Telescope, coming about because of a cooperative effort between NASA, the European Space Agency, and the Canadian Space Agency. The JWST surpasses the abilities of its herald. It utilizes cutting-edge technology and a design enhanced for concentrating on the universe in remarkable detail. Unlike the Hubble, the JWST conveys clear and sharp pictures of far-off heavenly bodies working primarily in the infrared range. This interesting component permits it to penetrate astronomical dust and capture divine objects that were previously stowed away from our view. With its massive 6.5-meter primary mirror made out of 18 hexagonal sections, the JWST dwarfs the Hubble's reflector size. Situated roughly 1.5 million kilometers away from Earth at the second Lagrange point, L2, it orbits the Sun in sync with Earth, ensuring a steady and continuous view of the universe. While looking into the far-off corners of the universe involves exploring light years, it also involves a type of time travel. The JWST uses infrared instruments to observe heavenly objects and events going back billions of years. The light emitted by these objects because of the expanding universe goes through redshift, moving from the apparent range to the infrared frequency or longer. Luckily, the JWST can identify infrared light radiated by heavenly bodies at extreme distances, empowering researchers to study the introduction of stars, investigate galaxy development, and examine exoplanet atmospheres. Its latest historic discovery involves identifying an incomprehensible mass of cosmic systems at the edge of the discernible universe. This finding challenges the validity of the theory of how things came to be, provoking a reassessment of our key cosmological assumptions. To better understand how we arrived at this point, we should take a short excursion through the history of space investigation. Early civilizations like the Greeks and Chinese laid the foundation for understanding planetary movement by observing divine bodies. Newton's laws in the 17th century gave a theoretical framework for space travel. In the mid-20th century, Edwin Hubble, an influential astronomer, made historic revelations in cosmology and observational space science. His observations uncovered that far-off nebulae were isolated worlds long past the Milky Way, changing our understanding of the universe's size and expansion. Hubble's law, established by him, showed that galaxies farther away were moving away at higher rates, giving proof of the expansion of the universe. The post-World War II history of space exploration marked the beginning of the space race, with the Soviet Union Sputnik in 1957 as the first artificial satellite in orbit, Yuri Gagarin's orbital trip in 1961, and the Apollo 11 moon landing in 1969, all crucial accomplishments. Fast forward to 1990, when the Hubble Space Telescope was launched, giving exceptional clarity and stunning insights into the universe. The journey from ancient observations to the technological wonders of the James Webb Space Telescope showcases the constant development of our understanding of the universe. It uncovered the boundlessness of space and changed fundamental thoughts in astronomy. Take the Hubble Space Telescope, HST, for instance. It mapped the famous Pillars of Creation image in the Eagle Nebula, revealing a star nursery formed by massive columns of gas and dust. Another significant accomplishment was the Hubble Deep Field, capturing a huge number of galaxies in a seemingly void patch of space. The HST also dove into exoplanet atmospheres, pinpointing components like water and organic molecules in distant worlds, alluding to the possibility of habitable zones beyond our solar system. Following the development of the closest observed supernova, SN 1987A, it shed light on the life cycle of massive stars. These achievements cemented the Hubble Space Telescope's legacy as a foundation of modern cosmology, dazzling the world with its incredible discoveries. Its replacement, the James Webb Space Telescope, was launched to expand on the technological advancements and lessons learned from a model of our understanding of the universe's origins, which today is explained by the prevailing theory of the universe's origin. Around 13.8 billion years ago, The universe started as a seriously hot and dense singularity, quickly expanding and giving rise to matter, energy, and fundamental forces. As the universe expanded, it cooled, leading to the formation of atoms, stars, galaxies, and the various structures observed today. The Big Bang Theory also explains cosmic microwave background radiation, light element abundance, and the large-scale structure of the universe. Despite being widely accepted, now the Big Bang Theory faced skepticism and challenges in its early days. Alternative models like the steady-state theory proposed a universe without a specific beginning, and concerns about proof supporting the initial singularity expansion and observed anomalies arose. Most of these objections were addressed over time, and a significant piece of evidence came with the detection of cosmic microwave background radiation in 1965, aligning with the Big Bang prediction. Space missions like COBE and WMAP, along with technological advancements, further supported the theory. Accurate measurements of cosmic microwave background radiation aligned strikingly well with theoretical forecasts. Enter the James Webb Space Telescope. Equipped with advanced infrared instruments that can look through cosmic dust, the JWST, working primarily in the infrared range, captures the oldest light in the universe and observes objects formed shortly after the Big Bang. Its infrared abilities allow it to concentrate on star-forming regions, celestial nurseries, and the formation of stars hidden from optical telescopes. Infrared light, with longer wavelengths compared to visible light, can penetrate interstellar dust, overcoming a limitation of the Hubble Space Telescope. The JWST can observe cooler objects emitting mainly in infrared, making it ideal for studying phenomena like exoplanets, brown dwarfs, and distant galaxies. As celestial bodies move away, their emitted light waves get stretched, causing a shift toward longer wavelengths, a phenomenon known as redshift. The JWST's infrared capabilities can detect these redshifted signals, capturing light from the early universe and offering insights into its formation and evolution. Energetic events like black hole mergers or new starbirths primarily emit in the infrared range, further expanding the JWST's investigative capabilities. The telescope can explore phenomena that would otherwise be hidden or invisible. The JWST supplements optical telescopes like Hubble by having enhanced sensitivity and the ability to detect infrared radiation. This ability allows it to peer further into space and dig deeper into astronomical history, revealing hidden astronomical wonders and providing a more comprehensive view of the universe's development. The JWST serves as our window into the earlier phases of cosmic evolution. Recently, it revealed something so astounding that it might prompt a reconsideration of the entire cosmological model of the universe. We've discovered enormous masses of galaxies at the very edge of the observable universe. These ancient galaxies existed just a few 100 million years after the Big Bang during the cosmic dawn. The puzzling part is that we're unsure how such enormous structures formed so early in the universe's history. This discovery might lead us to reconsider our understanding of the formation and evolution of galaxies in the early universe.